Hello everyone, welcome to Make 2 Explore channel. We thank all our subscribers and viewers for all the support and words of encouragement. Now let's see new project, IoT-based lock, version 2.0. Yes, we have slightly upgraded our previous version of the project. In this version we are going to add one more accessibility layer. That is biometric, means we will add fingerprint-based authentication. Also we are going to use different MCU development board. In version 1 we have used particle photon board, but in this project we will use ESP32 development board. So now, if user want to unlock this lock, then he or she should have valid RFID, fingerprint, PIN and OTP, means one-time password. Also we will program this lock system to keep record data of user entries with username and timestamp. This data will record it on our dedicated MySQL database which is hosted on our web server, hence the system administrator can log into that web portal and keep track of how many times this lock got opened. So, let's get started and see functional block diagram of the project and understand how project will work. So, there will be a RFID cards or tags which we will first register and link to authorized users. This will be done in initial RFID coding where we'll connect RFID reader with ESP32 development board, Nextion touchscreen display, fingerprint sensor, and solenoid lock. We'll also assign unique PIN for each individual user. Now, suppose, when any user places his or her RFID card on reader, if the card is valid, then next screen will appear on Nextion touchscreen display, which is fingerprint entry screen. It will prompt the user to place the finger on the optical fingerprint sensor. Like this. So, if user is authorized and already registered or enrolled, his or her fingerprint will recognized as valid user. Then next screen will appear on display which is PIN entry screen, on which user has to enter his or her PIN. Then if user enters correct PIN, this ESP32 board is Wi-Fi enabled. Hence it connects to internet through router, wirelessly. Then it connects to our Telegram bot, where we will send post request to Telegram bot API to generate unique OTP each time. This OTP will be then sent by Telegram bot to the Telegram app of user. Then, on next screen of touchscreen, user have to enter that received OTP. If user enters correct OTP, then and then only this lock will get unlock. Here in another post request we will also send record of the successful entry details to database hosted on our dedicated website with specific domain name like example.com or m2eprojects.tk, etc. We will send name, ID and other details of user who unlocked the lock with current timestamp and date. Hence the system administrator can log into that web portal from anywhere in the world and keep track of how many times this lock got opened. So in this way to open this lock, user should have valid RFID card, valid fingerprint, correct PIN and correct OTP. This was all about block diagram of the project. Now let's see hardware, setup, interfacings and circuit diagram of the project. Here you can see in the schematics, we have used these all components. All wire connections are given in color coding, so you can easily track them. Here is the NodeMCU ESP32S development board, main controlling component, an IoT development board which has onboard Wi-Fi capability. This is 3.5-inch Nextion touchscreen display. This is RC522 RFID reader module. This is FPM10A fingerprint sensor module. This is 2-channel relay board. This is 12-volt solenoid lock. And this is MB102 breadboard power supply module. We will share this diagram on our GitHub. Link will be given in the description of this video. Let's move forward and see each interfacing one by one in detail. Here is the schematic of interfacing of ESP32 and 3.5-inch Nextion touchscreen display. You can see here, Nextion display is powered with 5V taken from this MB102 breadboard power converter module. This module converts 9V battery, or USB power supply to 2 power rails, 5V and 3.3V. Nextion display requires 5V 500mA DC recommended power supply. So it is advisable that we should power Nextion display using external power source rather than via V-in pin of ESP32 if you are planning to connect more peripherals. Then next, TX pin of Nextion display is connected RX1 pin of ESP32 and RX pin of Nextion display is connected to TX1 pin of ESP32. You will get this circuit diagram on our GitHub account. Now let's see how to program this circuitry. Let's see some important points to note during this interfacing. It is recommended that you should download latest Nextion display library from their official website. We will share the link in description. ESP32 have 3 hardware serial ports. In this project, we have connected Nextion display to serial 1 and fingerprint sensor to serial 2. If you want to change this configuration, you can tweak with nexconfig.h library file as per your choice. AVR's software serial is not compatible with Nextion display and ESP32 interfacing. It throws errors, so we have to comment out following line from nexupload.cpp file of Nextion library. This line you should comment it out. Another workaround is, you can just rename nexupload.cpp in nexupload.h files itself with any other extensions like, for example, nexupload.txt or nexupload.tc, etc. Among above 2 workarounds, any one will bypass the nexupload error of Nextion library. After that, for proper working of Nextion commands, make sure that the baud rate of db serial, means serial debug, is set to 115,200 and next serial to 9600. Now let's see how to program Nextion display by loading one example from library. The next button. We have made detailed tutorial about Nextion display, how to make GUI on Nextion editor, and how to upload it on Nextion display. Link will be given in the description. You can also click on this I button. So, for this interfacing, we are using Next button example. Go to Arduino IDE. Before going forward, first you must check these 2 important prerequisites. 1. ESP32 boards installed or added in Arduino IDE. And 2. Nextion library added to Arduino IDE. If these requirements got fulfilled, then get started. Go to top left menu bar in IDE. Then go to File, Examples, then look for itidlib Arduino Nextion in this list. Here. And then load this next button example. It will get open a new window. Like this. In this example they have given that, when the button component on the Nextion screen is pressed, the text of this buttons will plus every time. Let's compile and upload this code into ESP32. Just make sure that you have selected correct ESP32 board and connected to correct COM port. That's it. Click on Upload button. Program will compile first, then it will get uploaded if there are no compile time errors. If you get any compile errors here, then you should debug the library issues, as we have discussed earlier. So, after program got successfully uploaded. Let's see the demo by using Nextion display touch screen. Is it working? Yes, it is. Text value of button is changing as we press the button on screen. In this way, we have completed ESP32 to Nextion display interfacing. Let's move forward and see next interfacing, RC522 RFID reader and ESP32 interfacing. We have schematic as shown here. We powered RFID module using ESP32's 3.3V pin. All connections in circuit diagram are given in color coding, therefore, it's easy to connect. To load the example program, go to Arduino IDE, add the RFID library if it is not added earlier. You can add this MFRC RFID library from Arduino's library manager itself. After that, go to top left menu bar. Go to File. Go to Examples. Look for MFRC522. Then load the dump info example from there. It will get opened in new window. This code is used to extract coded information on RFID cards. Let's compile and upload this code into ESP32. Just make sure that you have selected correct ESP32 board and connected to correct COM port. That's it. Click on Upload button. Program will compile first, then it will get uploaded if there are no compile time errors. So, after program got successfully uploaded. The demonstration of this tutorial shows that as soon as we place the RFID card on the reader will starts reading the coded information into the RFID card and ESP32 will simultaneously prints that information to the serial terminal. With the help of this program, we can read the RFID codes of the cards, or tags, which we are going to set as authorized in our main project. And we can assign them to particular users. Let's see next interfacing. ESP32 to fingerprint sensor interfacing. This is the schematics. Here you can see we have connected FPM10A fingerprint sensor to serial 2 of ESP32. We powered fingerprint sensor using ESP32's 3.3 volt pin. Okay, let's move forward and see how to program this circuitry. To load the example program, go to Arduino IDE. Add the Adafruit's fingerprint sensor library if it is not added earlier. You can add this library from Arduino's library manager itself. After that, go to top left menu bar. Go to File. Go to Examples. Look for Adafruit's fingerprint sensor library. Then load the enroll example from there. It will get opened in new window. In this interfacing tutorial we are not going to use software serial. So, let's remove this portion of code. And then include hardware serial header file. Like this. Since we are using hardware serial port 2. Let's change this MySerial to serial 2. Like this. This code is used to enroll or register the new fingerprints into sensor memory. After that, make sure that you have selected default baud rates. Then, let's compile and upload this code into ESP32. Just make sure that you have selected correct ESP32 board and connected to correct COM port. That's it. Click on Upload button. Program will compile first, then it will get uploaded if there are no compile time errors. So, after program got successfully uploaded. The demonstration of this tutorial shows that we can enroll and register our fingerprint to specific ID. You can assign 1 to 127 ID templates. Here in this project we have taken 5 templates of each user's one finger. We will require these IDs to authenticate individual user in our final code. So, in this way we have studied main 3 hardware interfacings of this project. Now let's see what our mandatory software setup for this project. Before you start the coding, make sure that you have installed latest version of Arduino IDE or Visual Studio Code Editor as per your choice of programming environment. Then install ESP32 board core into those IDEs. Please note that we will require following libraries. We will require Wi-Fi and HTTP client library. Then to interact with the Telegram bot, we'll use the Universal Telegram bot library created by Brian Luff that provides an easy interface for the Telegram bot API. We'll also have to install the NTP client library for fetching time from internet. We also need MFRC522 RFID library, Adafruit's fingerprint sensor library, and Nextion display library. Download latest versions of these libraries from their source repositories or from Arduino IDE. We will share the required links in the description of this video and on our GitHub page. Now, let's see final, all combined, code of the project. So, here we have included all the required libraries initially. The code is well commented, hence it is self-explanatory. Here you have to place your Wi-Fi credentials, SSID and password. Then you have to place your website details here the URL path. Then next is API key value. This API key is for accessing MySQL database. So it should be same as you included in postdata.php file. Then you have to include your Telegram bot token and the chat ID, which you got from the bot father, the master bot, during creation of your bot. You can also check out the video given below in description and in above I button, where we have explained this procedure of creating Telegram bot, obtaining bot token, and finding chat ID, etc. in detail. Rest of the code is just combination of all the hardware interfacings which we have seen earlier. Among them, main important function is send data to website. This one. Using this function we sent user entry, lock interaction data to our website. We will see this part in detail in next slide. Just note here that we are sending this string, HTTP request data, to the URL PHP script, which we have defined above in this code. Let me show you. So go to the top, the declarations section. Here in website details. This is the URL, and this is the PHP script, postdata.php, which we are calling. We are sending this data string, which contains API key, user ID, user's name, bank's branch name, and the timestamp, etc. And here, using this command, http.post, we are sending this data to our server. Confused? Let's see how this works with the help of graphical flowchart. In this project we have used ESP32 development board which controls and manages the locker system. For the time being, we have used this solenoid lock for demo purpose. This ESP32 board is Wi-Fi enabled. Hence it connects to internet through router, wirelessly. So, to store the locker data on web, we must need web space. We need web hosting server and dedicated domain name pointing to that server. Means, for example, our web server's address may look like www.m2eprojects.tk. In short, you need a website. So, whenever the lock got opened with proper authentication, HTTP post request will be sent to the server. We are sending data string, which contains API key, user ID, user's name, bank's branch name, and the timestamp, etc. We have seen this in our code earlier in this video. On your website, there will be a PHP script called postdata.php. This script will collect that data and insert into MySQL database. In this way, each and every valid locker entry data gets stored into our database. Now suppose you are the administrator of this locker system. You are at any location in the world. And you want to see who opened the locker, how many times lock got opened, at what day and time, etc. So, to access that, you need to first call website domain name from browser. There must be an authenticating login system where you need to log in with your admin credentials. Then, after login, another PHP script will get executed. Showdata.php. This PHP script will read the locker data from MySQL database and show it on admin's screen. So this is all about how the locker's data get posted on web server. In next session, we will see how you can build this system on web or on local machine. Now let's see next part of software setup, where we will learn how to host our PHP application scripts and MySQL database. One of the feature of this project is to have your own domain name and hosting account that allows you to store user entry log. The locker data, which comes from IoT-based lock. System administrator can visualize the locker log from anywhere in the world by accessing server domain. There are two methods to host these web server code. Method 1. Dedicated hosting space and a domain name. And next is Method 2. The XAMPP application. You can also simulate the website using XAMPP application server on local machine. In coming sessions, we will see both these methods one by one in detail. So, how you can get dedicated domain name and hosting. Let's see. If you want professional top-level domains like .com, .org, .biz or .net, etc. Then you will have to pay fees to domain registrar. But for academic or DIY hobby projects like this, we can use free domains which are available on internet. For example, .tk, .ml, .ga, etc. There are several websites on internet who register these domains for free. One of them, and most popular, is www.freenom.com. You can also search on internet for other registrars if you want. For web hosting, there are several paid options available. But if you are looking for learning and educational purpose like for this project, then you can go for free tier versions of cloud computing service providers like Alibaba Cloud, Amazon Web Services, Means, AWS, Google Cloud Platform, Microsoft's Azure, and Oracle Cloud, etc. Here, in this project we have used Alibaba Cloud Service and installed their CyberPanel. Means, the cPanel. We can access File Manager, PHP-MyAdmin panel and other features also from that cPanel. Let's find out. Log into your cPanel's dashboard. Enter your username and password credentials and sign in. After sign in, you can see here in cPanel. You can access all these functions. Now, let's see how you can host your website code. For that, you have to go to this Websites tab. Then, list the created websites. Here is our website, m2eprojects.tk. Go to its File Manager. File Manager will get open a new window. Here you can see, we have stored our web portal's code. These PHP and HTML files. In this way, here you can upload your web-related code in this public_HTML folder. We will share this code on project's GitHub page. On web portal of this project, there is PHP login system for IoT lock administrators sign in. So, we will have to create two different databases. One for PHP user admin login system and other is for IoT-based locks data. To create databases, you should go to here in databases. You can create, delete, and list the existing databases, manage their credentials, etc. Now, let's see how to create database. Click here on Create Database. You should select the name of website for which you want to create it. Then, give proper username and password. Note down these credentials. Name of database, its username, and the password. Save it, since we will require those to enter in our PHP files. Then click on Create Database. Here the prompt shows that database got successfully created. Now, let's go to PHP-MyAdmin for management. Here, click on Databases and then to PHP-MyAdmin. It will get opened. In PHP-MyAdmin, go to Databases. Here you can see our M2E login page database is listed. Now, let's add table into that database, which means let's create profile of our administrator. We have to add fields like user ID, email, and password, etc. For that we have given a SQL query code on our GitHub. Just copy that code into SQL query window of database and create table. Let me show you. So, go to M2E login page database. Then, select this SQL option. Here, note this message, run SQL query or queries on database named M2E login page. Go to GitHub link of this project, then go to codes, then to SQL queries for creating table and copy M2E login page table query. This one. Copy it and paste it here. And then press go button. The table will get created. Also, we have inserted username credentials with that. You can skip that and create your own. So, in this way, we have created database for our PHP login system in web portal of this project. Now, let's create database for our IoT locks data. For that go to CyberPanel again. Go to Databases and create new database. Give name as IoT Lock. Note down username and password. And click Create. Database will get created successfully. Now again, go to phpMyAdmin, then go to IoT Lock database which have created. Then, create table using SQL query, code given on GitHub. When table got created successfully, you can see, here in table, all the fields like user ID, username, timestamp, etc. The data of this project means the IoT-based lock, which will come from ESP32, will get stored here, inside this table. Like this, here you can verify it, as it got saved in our previously created database. All these values. Okay, now we have created our databases. Now, let's upload and update the web server's code. So, copy the web portal's code from project's GitHub page and upload on public_HTML folder of web hosting. Let's see how we can do that. Go to Cyber panel. Then, click on List Website. Here is our website. Click on the File Manager. Then new window will get open showing the File Manager and public_HTML folder inside it. Upload the web server's or the website's code here. If you uploaded the website's code in public_HTML folder, how you can check that, is it working properly or not? Go to web browser's address field and go to your domain. If everything is correctly configured, then you will see the login page. That's it. Web portal is working. Now, for login, you need an user ID and password, which you can get from your database. Here, username is admin and password is test. It is encrypted. Please note that before trying login attempt here, you should modify your PHP files. For that, go to File Manager. Edit and modify the database name, username, and passwords for home.php and authenticate.php files. Let me show you. These ones. You should replace these with your credentials. The world of web development could not have been what it is without XAMPP. It is one bundle of a web server application, database, and scripting language. So, before we move to the installation step, let's understand what exactly XAMPP is. XAMPP is a free and open source, cross-platform, web server solution stack package developed by Apache friends, which helps developers to create and test their programs on a local web server. XAMPP is an abbreviation where X stands for cross-platform, A stands for Apache, AIM stands for MariaDB, P stands for PHP, and the last P stands for Perl. So, XAMPP is one of the best Apache distribution that helps web developers to create a local web server for testing and deployment purpose. It was designed to be one of the easiest ways to install and run a development server. It is the most complete package. You can download XAMPP from the official website of Apache friends. Download and install the XAMPP from this link. You can also check out the link given in description as well as in above I button, where they have explained detailed procedure of installing and configuring the XAMPP application. After installation, when you run the XAMPP app, it will open interface somewhat like this. The XAMPP control panel. Here you can configure all these module comes with XAMPP, like Apache, MySQL, FileZilla, etc. You can also change their port numbers if you want by going into its config file. Now, to start the Apache server and the MySQL module, just click here on Start button. Module will get started showing its port number. Here, the 8080. Now, to test these, let's go to our web browser and type localhost:8080, the port number. Like this, and then press enter. We will get greeted by the default Apache page. Now, you must have thinking, how we can host or upload our website code onto this server. For that, go to this folder, htdocs, which is in the installation folder of XAMPP. Here, you have to create folder with the name of your website and put all website code into that. Like these, website 1, website 2, etc. Now, let me create one for us. Name it with like IoT lock. Note down this name because we have to put that in our localhost's URL path. We will upload our web portal's code into this folder. Like this. So now, how you can access it? For that, go to your browser again and put URL like this. Localhost, the port number, 8080, / and the folder's name, where we have stored our website's code. IoT lock. And then, / means the index page. Press enter. Yes, that's it, you can see our website's login page. This is how you can host multiple websites. You just need to create separate folder for each website. Let me show you another example. Type in browser's URL field, localhost, the port number, 8080, / website 1. This is another website. Website 1. Now, one more important thing, by going into this URL, see here. Localhost, the port number, 8080, / phpMyAdmin. You can access phpMyAdmin's page. Like this. Here you can create and manage the databases for your website. Just remember one important thing, you have to replace the credentials, names and URLs in your PHP files. See here, for example, this authenticate.php. Here you have to replace the host with localhost. And all other these variables values. The database name, username, and password. Fourth access level of this IoT-based smart lock is OTP validation. Let us see how we can generate one-time password. There are different methods of generating OTP. We will use simplest one. To generate the OTP, we need to first create a random number. For 4-digit OTP, we will create 4-digit random number using this code. It is very basic method, but it is suited for this DIY learning project. Once we generated OTP, we have to send it to particular user. Here, we can use different methods for sending OTP, like SMS, email, notifications, etc. But, as we are already connected to internet, we can use Telegram bot API to send messages to Telegram app of users and subsequently creating pop-up notifications. On this link you can learn everything about Telegram bots, their commands, and the info about the bot father, a master bot who ruled them all. You can also check out the videos given below in description and in above I button, where we have explained in detail about the procedure of creating Telegram bot, obtaining bot token, and finding chat ID, etc. Once you get your HTTP API bot token and chat ID, go to main source code. Here in the source code, you can see we have included this library, Universal Telegram Bot. Then next, here in these credentials related to Telegram bot API, you have to replace your bot token and chat ID. Okay then, next, here in callback function of pin enter button. We have used this random function to generate the random number within range of 1000 to 9999. We have created this message string in which we embed our OTP. Then with function bot.sendMessage, we send the OTP string to the chat ID of user. Here we have used only one user's Telegram chat ID for demo purpose, but we can add multiple. So, in this way we can generate and send the OTP for this IoT-based project. Now, we will see the final demo of the project. So far, we have seen hardware-software configurations, schematics, interfacings, and code of the project. Now, let us see final demo of the project. So, Here you can see, we have assembled the circuit of this project, IoT-based lock, version 2.0. You can compare it with schematics given here. We have connected ESP32, RFID reader, fingerprint sensor, solenoid lock, and Nextion display. We have powered ESP32 with this power bank through this micro USB cable. And, with the help of this MB102 breadboard power supply module, we are powering 5 volts relay module and the Nextion display. For solenoid lock, we have used this 11.1 volt LiPo battery separately since it requires 12 volts. RFID reader and fingerprint sensor use 3.3 volts from ESP32 itself. So, this is all about components used in this circuit and how they are powered. You can get this schematic on our GitHub account. Links are shared in the description of this video. Okay, now, let's power on the circuitry. At first, ESP32 will connect to internet through Wi-Fi. And then, fetch current time, day, and date from NTP server. Then display it on Nextion. So, here on display, you will see graphical user interface prompting us to place RFID card on the reader. This lock have 4 levels of security. Means, to open this lock user needs to place valid RFID card, valid fingerprint, valid PIN number, and, finally valid OTP, one-time password from the Telegram app. These 4 levels have unique values for each individual authorized user. System administrator of this lock will register and enroll the users during programming and installation of the lock. Once authorized users' data is fed into locker system, only those users can open the lock. Let's see how it works. So, unlocking process will be like this. If anyone want to unlock the lock, he or she should have valid RFID card. Authorized users' UIDs will be registered during programming. Then, for unlocking, user need to place the RFID card on the reader. If the UID of that card is registered in ESP32, means, if the user has valid RFID card, only then, the next screen will appear, which is fingerprint entry screen. Here user is prompted to place his or her valid enrolled finger on the fingerprint scanner. If user's fingerprint is valid and already registered and associated with this RFID, only then, the next screen will appear, which is PIN entry screen. This display is touch screen. Here user has to enter valid PIN associated with his or her account. If user enters valid PIN, only then, the next screen will appear on display, which is OTP entry screen. When user enters valid PIN on previous screen, a 4-digit OTP will be sent on Telegram application of user. Yes, you must have guessed why we find out Telegram user ID and entered that in Telegram bot API. To send OTP to particular user's Telegram account, we must need its user ID, or, you can say, the chat ID. When user receives OTP on Telegram app, it should be entered on OTP entry screen. So, if user enters correct OTP, only then, lock will get unlocked. And, the details of valid entry, username, ID, and timestamp will be sent to website or web portal by HTTP post request, as we have seen in source code. Let's see how this works in real time for another card. Let's check another RFID card, U2. Put this on reader. Since we have registered this card also, we will get a valid user screen. We will then presented with the fingerprint entry screen. Place your enrolled finger on scanner. If finger is correct, then we will presented with the PIN entry screen. Enter PIN specific to this user. Press enter. Here you can see, we will get OTP on our Telegram app. Check and read that OTP and enter on next screen. The OTP entry screen. Here, like this. Then press enter. If OTP entered correctly, lock get unlocked and user is greeted with welcome screen. Lock remains unlocked for 5 seconds only, then it automatically gets lock again. Here this blue RFID tag is not registered in ESP32. So if we place this on reader, screen will show invalid user message. We have registered only these RFID cards, the white ones. Now, let's again use this U1 card. Please note that even anyone knows or guesses the PIN of user unless he or she enters correct OTP, lock cannot be opened. Likewise, if anyone enters wrong PIN or wrong OTP, lock will not open. Screen will go to normal mode again. So, in this way, we have completed this project. If you face any difficulty in replicating this DIY project, feel free to ping us on Telegram, or you can also send us email at info@make2explore.com. We would be happy to help. Thank you.